Good morning, good afternoon, everybody. My name is Milene Aguiar, and I'd like to welcome Robison De Melo, who will present the webinar today. Just a few reminders before we start. We will have time for questions and answers in the end of the presentation. So feel free to send your questions using the Q&A box in the bottom of the Zoom page. Please make sure you are sending to everybody, not only to the presenter, because he won't be seeing these during this presentation. Thank you, Robson, for being here. Welcome. Feel free to introduce yourself and start the presentation.
Okay, thank you, Milene. Greetings, everybody, and thank you very much for joining us on this webinar. Okay, so I would like also to thank you, Stuart and Gary, for this opportunity. Okay, and my name is Robson, and we're going to be presenting. We're going to be sharing thoughts. Okay, if I can make my screen work. Hello. Yes, now I can. Okay, so we're going to be sharing thoughts. We're going to be talking about the minimum night flow analysis with N1 factor, measured N1 factor, okay, to get a 90-day factor for an accurate NRW assessment. Okay. First, okay, minimum night flow. The analysis of minimum night flow. What is for? What can help? Okay, the minimum night flow help us. Okay, it's for a better understanding of the zone characteristic. Okay, so we can identify the area, how the zone is operating. It's to assist in leakage reduction. Okay, to measure efficient distribution of water, to have a guaranteed storage, to assist in water conservation, to assist in burst frequency reduction, aiding to increase customer satisfaction as well, helping to understand what are the problems, assisting prioritize NRW reduction interventions, and monitoring over time help us to learn the attrition rate of the infrastructure. And finally, of calculating the water balance, okay, in a bottom-up approach. Now, I think most of you are familiar with this graph, okay? So that's a typical minimum night flow analysis. What we do, okay? When we analyze the minimum night flow, we can identify what are our normal night users, okay? What could be a non-domestic use metered, or non-domestic night use unmetered, and domestic night use as well. A background leakage, okay? What could happen in connection leakage, in main leakage, and installation leakage, okay? And get what we say our excess night flow or a burst, okay? What it can be reported or unreported bursts. Now, some practical data analysis, actually some challenges that we get when we try to get the minimum night flow. For example, if you want to know a minimum night flow from a reservoir area, okay? So there are several cases where we have an intermittent supply, okay? Where every night they go and close the area and we can't get any minimum night flow to analyze how is the area. Okay, there is no minimum night flow for leakage analysis. And as you can see, what is also bad, when we start again, okay, so we have some spikes due to the manual valve opening, okay? So actually we have to be very careful when we operate the valve, okay, to not have that, because we can cause more and more bursts. Like on this case, the only time possible was to get this time to get the minimum night flow that we could start evaluating or analyzing how was the system. Another one, okay, is in PRV. So suddenly you have flow, almost a straight line, and pressure up and down, pressure upstream and downstream dropping, and no pressure at the critical point. Okay, so we can go evaluate, and then we identify there was bursts, and then they fix it. They closed, they did a shutdown to fix the leaks, open again, and then everything came back to normal. And suddenly, somebody goes and open a boundary valve, and everything go back to, or even worse. As you can see, we had that flow before, and now we are having that flow. Okay, so make worse. But the minimum night flow also is basically to help us identify on that. Another one is you evaluate, and suddenly you have everything goes down. Upstream pressure, downstream pressure, critical point. Okay, so something triggers say, oh, there is something wrong on the zone, and then identify that there was a shutdown upstream of the area to fix a leak. So everything goes down, and then they open, and everything goes back to normal again. Okay. Or even a zone bridge. So everything's running, and then our minimum night flow shows, oh, you evaluate one of the area, you say, oh, the minimum night flow drop. So that's great. And then when you analyze with the next boundary or the next zone close by, you see there is a bridge between both. Okay. So, and then you go there, fix again. Okay. And actually, actually somebody went there and opened again. Okay, so there was a low pressure complaint, and the first thing they did, open the boundary. Okay, so the minimum night flow is our trigger, is what we do analyze, what we monitor to identify situations like that. Okay, and now, talking about what we said, the minimum night flow analysis and the N1 factor to identify our night day factor and to have an accurate NRW assessment, okay? I'm just putting here a case study for you. Just gonna give some information about the area. The area is 9.96 kilometers of main and reticulation pipeline. They have 755 domestic connections, 155 non-domestic connections. So that gives us a total of 910 connections. And as you can see, it's a mixed consumption area, okay, between domestic and non-domestic. Another thing of this area is 65% of the total pipeline was replaced, okay? And was replaced for HDPE, okay? And 81% of the total reticulation or main, okay, is plastic pipe, or between PVC and HDPE, and the rest is metallic pipe. And in this area, at the moment, there is no pressure control in the area, okay? And it is a gravity system. Now, we start evaluating that, okay? We get 30 days of the minimum of the pressure and flow on inlet pressure and inlet flow to the area. Okay, as you can see, our minimum night flow in this case goes up and down. Okay, so that's a raw data. Okay, so many of this we have like a situation like zero flow for, I don't know, some about a disturbance, electronic disturbance or something like this. So to really evaluate that, so we have to mine it. We have to start mining this data, okay? And then after mining this data, we have a graph like that, showing the minimum night flow, a bit more stable, okay? But during 30 days, we have situations of up and down, okay, in the area. That is the time that we have, like right now, because of the pandemic situation, like lockdowns and people cannot work and everything. So it's not a constant, okay? So to have it more realistic of this data, what we do, we average that data in 24 hours, okay? And doing that, we have a more clear graph, a more average information of the area, and a more clear that we can visualize it properly, okay? But as you can see, my graph is a bit different. I start from 12 midday to 12 midday, and I leave the minimum night flow in the middle of the graph. That shows a little bit better. So although it is not, I learned it a long time ago, okay, but a friend of mine says that is one of my signature. But anyway, here we can identify that now the average minimum night flow of this area is 35 cubic meters per hour, okay? So now just doing that quick calculation to identify how bad is the area or how good is the area for leakage, okay, for leak detection. Taking this average with the minimum night flow, okay, we have a leakage factor of 0.57 or 57% of leakage probability. But, okay, remember, it's not an area, it's not just a domestic area, okay? We will have mixed, there is a mixed consumption, okay? So now, in the same period, what we did, we identify the large consumers in the area, and also a 10% sample of the domestic meters, okay? Also evaluating, mining, and calculating this, okay, using some data evaluation for that. We can categorize it in domestics, in priority consumers, large consumers, commercial institutes, and categorized by consumption of them. We have what we did measure at night, the numbers that consumer that was measured, and we extrapolate it to identify what is the total minimum night flow. Oh, sorry, the legitimate night users, okay? And we can get, extrapolating it, we get a graph like that. Also doing the average in 24 hours, okay? We got that our legitimate night users is 18 cubic meters per hour. Now, just redoing the quick calculation again to identify the leakage factor. Now, we know that our excessive night flow, or our burst, okay, is 16.5 cubic meters per hour. Okay, so it's the minimum night flow minus the legitimate night users, we get 16. And if we keep the same average flow, okay, now our leakage factor drops from 0.57 to 0.27, or 27% of leakage probability. Okay, it doesn't mean there is no leak. Of course, there is leakage. Almost 30% of the minimum night flow is leaking. However, now we can identify, we can be more precise, or we can think about how we go gonna do the leak detection. Okay, so the first was almost 60%, so that would be easier to identify leaks, and now is a little bit more difficult. Okay, so we have to pay more attention. The inspector has to pay more attention to identify these leaks. Okay, so that's the minimum night flow analysis for leakage. So now, in the meantime of this, let's identify what is the other components of the minimum night flow or the profile of the area. Okay, so for that, we measure the N1 factor. How we do that? So we go on site at nighttime, at minimum night flow, okay, period, minimum night flow period, and we measure it. We do what we call the drop test, okay? Doing this drop test for this area, okay, we start with what we say the L0 of 34 cubic meters per hour with a pressure of 20 meters. And we drop it until we get a flow of 25 cubic meters per hour and pressure of 6. Actually, we drop the pressure to identify the flow. Okay, so we escalonate the pressure at least 3 times, as you can see, for us to get more precisely data to calculate the N1 factor. Okay, now we do a calculation. So based on new FAVAD and N1 update references that was presented from Alan, Julian Thornton, Cobus, Mark Fontos, and Mark Shepard, and that was presented in Water Loss 2018. Okay, so we can evaluate and we can calculate this N1 using the drop test, as we can using this the night user, the measured night user. Okay, I'm not going to get deep on the calculation, but using the factor and using the FAVAD, okay, using the fixed leakage and the variable leakage, okay, we get a value of 0.728 as a N1 factor. Okay, actually it's showing on the side here. Okay, now having this information, okay, we can do the components of minimum night flow analysis. Okay, we can identify not just the minimum night flow, but we can identify the profile on the system, right? So where we have our minimum night flow into the area, our legitimate night users, our excess night flow, okay, or our burst, and also our background leakage. Okay, I think I'm going too fast, but anyway. Now, with this with that information, with the N1 factor, we can identify our night-day factor analysis. So as you can see, a graphic here of the real measured N1 data. If there was a N1 of 0.5, okay, we would have this profile. And if it was N1 of 1.5, would have a lower one, a different profile, okay? And from that, we can start our initial NRW assessment data analysis. So, and for that, we have to get a kind of methodology for that, because we're going to be based on a billing system, okay? And we have to get more precise information. So what we do, we get the first month, the data of the first month, and then the second month. But we get the data from when you start the reading on the first month, with the end of the first reading. And from the other side, we get the starting of the second reading, second meter reading, and the end. And we use the data, what is between these two data. Okay? So that's the period that we use for the inflow and for NRW assessment calculation. Okay, so it's gonna give us a better accuracy of the data comparing the inflow with the billing system. Okay, and for that, we can have a summary of our initial NRW assessment. On this case, we have our SIV, our system input value, volume of 1,466 cubic meters per day. Our build meter consumption gave us 1,098 cubic meters per day. What we would have here, NRW by volume of 368 cubic meters per day, and NRW by percentage of 25%. Okay, so doing our calculation based on our minimum night flow, what was a measure at DMA inlet meter, our legitimate night flow, also measured and estimated, okay, with a best estimation. We can have our net night flow, that was calculation, just minimum night flow minus the legitimate night flow, okay? So, using the tested of N1, the N1 tested of 0.78, we get that our night day factor is equal to 20.1 hours, okay? Giving us a 332 cubic meters per day of real losses, okay? Now, I'm just putting the extremes here, okay? If on this case was, if our N1 was the 0.5, what was basically a rigid pipeline, metallic pipeline, that was no deformation on the holes, okay? So we would have a 350 cubic meters per day of real losses, what is 5% above of our calculation. Now, if you have on the opposite side, okay, a plastic line, completely plastic pipe, flexible pipe, okay, we would have a 279 cubic meters per day of real losses, what is 19% less than the calculated one, okay? And now we would have also, if using the old methodology where we could go, where the N1 factor could go from 0.5 to 2.5, okay? And using this maximum of 2.5, we would have about 270, okay, of real losses, and what is minus 46% of the calculated or this tested real losses. So as you can see, that's a huge difference. And that is what I was about to show you. So it's important we do a test and we do a night flow analysis, okay, with our N1 tested on site, okay, because when we do estimatives using also, it's not wrong, okay? But when we do use the estimative using the type of pipe and age of the pipe, okay? So it can lead us to an error, as you can see here, okay? It can lead us to error, and that error, so we think the area is good, is going well with 200, about 200 or 270, 279 from this case, okay? But actually you are losing another 40, 50 cubic meters per day, okay, on this case. So my point is it's very important for us to start doing the N1 test on site, to drop the pressure, evaluate it, calculate the N1, so you have a more realistic NRW assessment of the area. And as I said, I believe I went too fast. I'm not sure if everybody could help, could follow me, but that's it. As you can see, our 32 and our difference of that. And that's it. Thank you very much, everybody. So if you have any question, Melanie?
Hi, Robson. I was struggling with my video here.
I'm sorry, I was thinking that I spoke, and nobody did hear me.
Okay, so you finished your presentation in less than 30 minutes. That's great. Let's see.
Sorry.
Oh, that's perfect. I'd like to ask, does anybody has any questions? Because we didn't have any questions here in the Q&A box. Okay, so Share Site is asking, can you describe data mining?
Okay, data mining is when you get the data, you get your raw data, okay? And then you start analyzing what is wrong on that data. For example, sometimes you get like spikes, okay, of 0 that shouldn't be there because you have a situation where you are getting all data, like on this data is every 15 minutes, right? So your pressure doesn't change. However, your flow dropped to 0 in 15 minutes and have only one spike of that. So that's not realistic what's happening in the system. That could be some spikes, electronic spike in the data logger that can occur that. So, and when you do a data mine is exactly that, to extracting what is something abnormal of the data. Okay, so that is what we express a data mining. Everything that's abnormal on the data. So that's what is very important when you do measure flow. When you do a flow analysis, okay, it's very important to have next to it the pressure analysis, because if something happened on a flow and you don't have the pressure, okay, information, you're not sure. Maybe for a period of time there was your flow went to 0, but you're not sure if it is a logger problem, a data problem, or something else. But if you have a pressure together, so you really can identify, so that's not it's not a faulty, or it's a spiky, or if the pressure drop as well, you say, okay, there is somebody closed the valve. So you can identify what is happening on the system. Okay, so I hope.
Thank you, Robson. We have 2 more questions here.
Okay.
Next one is from Michel Mates. He's a great friend of mine. So Hi, can you calculate N1 in intermittent systems?
Can you calculate N1 in?
Intermittent systems. Sistemas com intermitência.
Yeah, intermittent systems. I would say, well, you can. However, it depends where. Okay, you just have to remember one thing: to identify the area, to identify the N1, you have to know, you have to practice, you have to put this test or the drop test during the minimum night flow. Okay, so you have to know if normally your intermittent supply happen at night time, so you have to open your area and leave the water flowing for a period of night, so you can perform that drop test and then calculate. Yes, you can. It's not, okay, intermittent supply is not the best way, but you can. It's just going to give you a different numbers, and it's going to be more accurate, of course, if you do a drop test. But remember, you have to keep the area open during the time you're doing the test. Okay. I hope.
Abu Bakar no Diallo, I'm sorry if I didn't pronounce it correctly. No. How did you pass from 30 days data to 24 hours?
Okay. You do an average of that. So you get, okay, you get your 30 days data. Okay, so where you have your, let's say for this case, it's 15 minutes, right? So you average starting from midday. So every 12 o'clock for every day, you average 12 o'clock from day 1 with day 2, day 3, day 4, and to the day 30, and do the same for 12 o'clock, 15 minutes, doing the same. Okay, so you are averaging every specific time with specific flow, averaging it in 24 hours. That I believe it, and that's it.
Okay, so is this presentation available for sharing for future reference? This I'll tell you, Nia Wade is asking, all the presentations, all the webinars will be available on the YouTube page, IWA YouTube page. If you need the presentation, you can always email Robison. His email is in your screen, and ask if he can send it to you. But the whole webinar will be recorded and available on YouTube. Just access the Water Loss Specialist Group IWA page, okay? Another question from Abu Bakar again. Which tool do you recommend to calculate non-revenue water from minimum night flow measurements? Do you use a specific tool or just an Excel spreadsheet? What do you use?
Okay, I do use a Excel spreadsheet. Actually, there is no, I don't have any software doing that. Actually, it's basically in Excel.
Okay. Kevin Romain from Trinidad and Tobago. Can you just use the least minimum night flow for the 30-day period? Can you use the least minimum night flow for 30-day period? Se você pode usar os últimos.
The least? I'm sorry, I didn't understand.
Yeah, Kevin, if you want, you can turn on your camera, the lowest. Can you use the lowest minimum night flow for the 30-day period? The lowest. He wrote it now.
Okay, let's put it this way. You could, but it's not recommend. I don't recommend it, because remember, we have different situations in the area. From Monday to Sunday, we have different consumptions, okay? Remember, for us to analyze something, as many as data we can get, as better the analyze will be, okay? So if you only use one minimum night flow to evaluate what's happening on your system, that is not gonna give you, how can I say, an accurate information. So from Saturday or from Monday to Sunday, the system change. So like on this case, okay, I have, we have commercial buildings, commercial consumers, we have domestic consumers in the area, there are hospitals, so it's different. So and the day by day, there is a different consumption. So for us to get an accurate NRW assessment or to get to the minimum night flow, the best would be doing that. We average at least a 7 days period. So we can have a week profile of the system. Okay.
Okay. Next one, Felipe Mapa is telling great presentation. Could you explain again the calculation of L and U? How often during the year do you update this calculation?
Milene, unfortunately, I couldn't hear you properly. Say again, it's breaking up.
You can open the chat box in the bottom of the page if you wanna read this. But he is asking you to explain again the calculation of the LNU. And how often do you update the calculation?
Okay. Okay, the LNU, okay, basically use the larger consumers. Okay, so that's a pure value. Okay, so you go to the large consumers and then you put a logger on their flow meters. So you get that their real consumption and their real consumption at nighttime, at the time of the minimum night flow. And to measure every consumers, unfortunately, right now it's impossible because we have a lot of mechanical meters. Okay, so in the future, when the smart metering starts, that's going to be very helpful for that calculation. But right now, what we normally do, we get a sample of 10% of the consumers, and we choose from the billing system. Okay, we choose the consumers that is taking like 100 cubic meters per month, 90 cubic meters, 80 cubic meters, and then we get samples of that. Okay, and of course, we extrapolate that, the numbers that we have, we average the numbers that we did read with the numbers of the consumers in that category, and we get estimated consumption during the night for the entire system. Okay. So that's how we do calculate. And okay, how often? I would say if the system, okay, when you start an area, okay, it's important to know what's happening on the area before you put the pressure reducing valve or before you start pressure management in the area. Okay, so it's important to know how is the area. Like this one is initial in RW. Okay, so after you do the leak detection, you repair the leaks, and you do, even if you put a pressure management in the area, so you do again to identify what is your new trigger line, what is your new system, how is operating your system. Okay, and that's, and I would say if everything is running okay and you start monitoring it, if everything is running okay, it's fine for a year just to identify what is the attrition in your area, how your system is losing. Okay, would be every year, depending. It's each area is different. It's area by area. okay? Some area can spend like 2 years and it's perfect, but there are areas that every 3 months, you have to do some action.
Okay, Robson, we have another information here that's great. It's regarding a question that Diallo made about which tool we will recommend. Katie Stanton Davis is telling us that WLRNA, their company, is developing online software released later on 2021, which splits inflow into leakage and consumption. Earlier versions have been used even in intermittent supply situations. It's based on Alan Lambert's equations. So it will be released later on 2021, and we will split the inflow into leakage and consumption. So I think if anyone needs to get these tools, this information, just have to access.
That's perfect.
Kevin Romain from Trinidad and Tobago is telling, do you have an allowable leakage usage figure or factor when considering minimum night flow?
Okay. Actually, that is, okay, by experience, everything that is above 25% when you do the leakage factor, everything that is above, that's going to be easier to identify the leaks, okay, to find the leaks, okay. Everything that is below 25, okay, that's going to be a little bit more difficult, and the operator should pay more attention, and actually we should be using more ground microphones and situation like that. So that's the trigger, okay. That's I believe most of us use that.
Okay. Any more questions? Kate, you told us about this tool. If you can, or if you want, you can turn on your video camera and talk something about this. I'm not sure if okay. Hi, Kate.
Hello, Kate.
Hi there.
Always nice to see you.
Nice to see you again, Melanie. Yes, we've been working, Alan Lambert and I, on some new online software, which, first of all, from a night flow test, calculates a value for N1 at a specific pressure. And then furthering on from that, we're developing a piece of online software which, once you know that value of N1 at a certain pressure, will then go to continuously split the inflows into consumption and leakage. If anybody has a technical question about that software, I would suggest they direct it to Alan rather than me, because he's got, the software is based on his equations. It's something that has been used in the past in previous forms, in sort of Excel spreadsheets on customers with intermittent supply. So it has been used before. In South America, Alan, is that correct?
Yeah, I think Julian did use that.
I don't know if it was Julian, but Alan, can you unmute yourself and just clarify?
Yeah, okay. It was on a project in Mexico for about 2-3 years ago, and it was based on the equations that developed for the 2017 water loss, where we do a very carefully carried out N1 test, and then from that we can extrapolate the relationship between N1 and pressure, which you saw in Robison's presentation, how the M1 drops as the pressure drops. So it calculates that equation. It also calculates the equation between the leak flow rate and the average zone pressure using the full Farad analysis. And what that means is that if you do a series of M1 tests carefully throughout the year, let's say every 2 months, then you can use that test for the next 2 months to split your flows on your real-time incoming data system. So from the N1 test, we use that as the key to unlock the door to understand how to do real-time flow separation on zones. And that has been used in this city in Mexico now in real time for probably 70 or 80 for intermittent supply systems, gradually turning the whole of the system from an intermittent supply into a continuous supply. I think it's gone up now from about 50% intermittent supply up to about 75% at the latest time, as it's applied to one zone after another. And it will even split intermittent flow. That's the good thing about it. So I'm quite excited about this one. And I think it will be a lot of use to places that do have intermittent flow.
Oh yeah, definitely.
If anyone wants to access this software, would you like to share the site, Kate? The website?
Yes. If anybody would like an early demo a bit later on in the year, I'll just put in my email address.
Thank you, Kate.
Thank you, Melanie.
So if anyone wants to contact Kate, her email is in the chat box, Q&A box. I don't know how it appears for you. And the website is over there as well if anyone wants to access the information. Okay, we don't have any other questions. Kate, Alan, thank you very much. And Robson, would you like to tell anything else, or we can finish the webinar right now?
No, I think it's fine. Well, if anybody has any doubt as well, there is anything that can help, so my email is on the screen, and we can get in touch. And that was great to have Kate and Alan together here. So last time I saw you guys was in South Africa. So it's great. It's such a pleasure to see you guys again. And of course, everybody also that did join us. Thank you very much. Thank you.
Robson, thank you very much for a great presentation. And we are closing the webinar right now. Thank you very much for all the audience. Bye.
Thank you. Bye.
Thank you. Bye-bye.
Bye.